So today we're going to look at Laplace transforms. First of all, you need to remember all of these. These are the most common ones. So Laplace transform of 1, e to the at, t to the n, sine of bt, and cos of bt. You need to know those inside out and backwards for when you do the inverse Laplace transforms later on. Those are really fun. So right here we have similar to up here, except we have e to the at in front of them. And if you notice in here, the Laplace transforms are exactly the same as what's up here, except we've replaced s with s minus a. So that's what our first rule is right here. If you have the Laplace transform of e to the at times some function, just ignore the e and take the Laplace of that function. And then when you're done, you can replace that s with s minus a. Our second rule here, you need to take the Laplace transform of the nth derivative of f at t. This is the general form of the rule. So you start off with s to the n, the Laplace transform of f at t. So you're going to ignore the derivative for when you're taking these ones, and you just go down the line. So the n minus 1th derivative, n minus 2, blah, 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 blah. You start with s to the 0 in front, s to the 1, 2, 3, 4, until you get up to s to the n minus 1. And here, if you don't want to remember this, you can just remember these two. This is the same thing written out for n equals 1 and n equals 2. These are the only ones really that you'll see on any sort of test or exam. And the last rule that we have here is if you have the nth, we'll start on the side. The Laplace transform of t to the n times f at t times this negative 1 to the n equals the nth derivative of the Laplace transform with respect to s. So we'll do a couple of examples here. First example, we have the Laplace transform of the derivative of cos of 2t. Now, if you're asking, can I just take the derivative of cos and then take the Laplace of that? Yes, you can. Sometimes, though, that derivative, for other functions, the derivative can get really ugly, or maybe you don't know how, or maybe you can't at all. Or maybe they just ask you to use this formula in a test. So we have the derivative of cos of 2t. So we're going to take our formula for n equals 1 from this page. It's just right here, s times capital F at s minus f at 0. So that looks like this. We have s times Laplace transform of cos of 2t. So that's our f at t is right there. Minus f at 0. F is right here. So it's the cos of 0. We know our Laplace transform of cos of 2t is s over s squared plus 4. So we just put that s in. So it's s squared. And minus cos of 0 is 1. So then we just solve that out, and we get negative 4 over s squared plus 4. That one's fairly simple, straightforward. So we'll take a look at this one now. Laplace transform of t squared times e to the negative 3t times sine of 4t. So we remember our rule about the e, so we're just going to drop the e, and we have Laplace transform of t squared times the sine of 4t. So here's that formula we were looking at before. Now our f at t here is the sine of 4t. T to the n, we have t squared. So yeah, our n equals 2, and our Laplace transform here is just the Laplace transform of sine of 4t, which is 4 over s squared plus 16. So if you write all that out, our n equals 2, so we have negative 1 squared. That's going to go away. That's nice. Times the Laplace transform of t squared times the sine of 4t equals the second derivative of 4 over s squared plus 16 with respect to s. And that's just taking the derivative here. You're pretty smart. I'm sure you can do that by now. So you end up with 8 times 3s squared minus 16 over x squared plus 16 cubed. So now we've got it into this form where we have e to the at times something. And we've already taken our Laplace of that something that's right here. So we're just going to replace all the s's in here with s minus a. And of course, from up here, our a is -3. So we end up with this big ugly thing here. And that's all there is to it. If you can remember those 3 steps, you can take the Laplace transform of pretty much anything. Math isn't so hard when you have the right tutor. Be sure to check out the description for links to other courses and topics. Also remember to tell your friends about the TheKFully channel.